Hi, good morning, everyone. So today we are going to discuss about one-way analysis of variance, or one-way ANOVA. Okay, just a bit of review what we've learned so far. Yeah, so before we have discussed concerning hypothesis test in the context of one sample and two sample test. Yeah, for one sample test, what we do is we test a hypothesis claim concerning one populations. Yeah, let's say that the claim is concerning one city, and then the claim states that the monthly income of that city equals to 1,000 US dollar. And then what you do, yeah, usually is you pick several respondents as a samples and then check whether the statistics of the samples are indeed close to the stated claim. Yeah, that's what we do in one sample test. But in two sample tests, the claim is not concerning one specific populations, but two different populations. For example, we try to compare the monthly income of the citizens for city A and city B, and the claim, the hypothesis claim, could be the monthly income of city A and city B are similar one another, and what we do is also similar. We pick several samples from population city A, and we pick several respondents from city B, and then we test the statistics. Yeah, we calculate the statistic and see whether the statistics inference are indeed support the claimed hypothesis. Yeah. So in one sample test, we talk about one populations, a claim concerning one population. In two sample tests, we test a claim concerning two different group or two different populations. Yeah. And then the questions that rises is, of course, what technique that we use if we want to compare the means of multiple groups. Yeah, multiple means more than two groups. It can start from 3, 4, 5, 6, and so on. Yeah, so in this context, we would like to check a claim concerning 3 or more populations. Yeah, it could be maybe until 5, 6, 7, or maybe until 100. It can also very well be. And the hypothesis claim that we want to check is whether the mean value of population 1, 2, 3 until C is similar one another, or whether there is a difference in the mean value among population 1, 2, 3, 4, and so on. Yeah. Difference here means that if even if only one populations, of only one population is indicated difference from all the remaining group, it can it can also already support that not all mean values are equal. Even though only one populations has different means value, then the null hypothesis that states all of the populations values are similar can be rejected. Yeah. So what technique that we use if we want to compare the means of multiple groups or more than two groups? The technique is ANOVA. Yeah. So let's now first discuss about the basic philosophy of ANOVA. Yeah. And to do that, I would like to start with an example. Yeah. So suppose that you are a marketing manager of a personal computer company. Yeah. And then the computer company sell computers to students of four different universities. And for the pricing decisions, whether you want to apply the same price for university A, B, and C, you have to investigate whether the monthly income, average students, for the average students' monthly spending in university A, B, and C is different or similar. If they are similar, then you can apply the uniform price policy. If not, then you have to take another policy, for example, differentiated pricing schemes. Yeah. So in this case, let's start with a simple one. For example, you want to check whether students' monthly spending is similar between three universities, University A, B, and C. And then, yeah, what you do is, of course, you pick several respondents from University A, B, and C. Yeah, to calculate the statistics, yeah, and to see whether the claim that the average students monthly spending among A, B, and C are indeed equal or not. Yeah. And then how we do it? How can we do it? Yeah, of course. So let's see. Yeah, first, of course, from each of the populations, you pick several respondents as samples. Yeah. For example, one. So let's say, for example, in University A, the first respondent states, okay, my monthly spending is about 1.4 million. The second respondent is 1.5 million, and so on. Yeah. You do it for University A, and then you also pick several respondents from University B and University C. Yeah. And then what you do, yeah, and then if we see, yeah, this is only small size of sample size. Yeah, we can see that, if we pick if we draw a simple scatter plot here, yeah, and then this is uni A, uni B, sorry, and uni C. Yeah, for example, this is 1 point. Okay, in University A, the first respondent states that it has 1.4 million spending. The second respondent is about 1.5. The third respondent is 1.7, and then 2.3 and 2.5. So let's see, this is the data, the dot plot of the data in sample. In sample B, yeah, the first respondent state 1.3, the second respondent 1.4. Sorry, this is 2.5. Yeah, 2.4, 1.4, and then 1.6, yeah, about here, and 2.2 and 2.6. Yeah, 2.6. And we do it also for University C. The first respondent states that the minimum income is 1.3 and 1.6 and 1.6 again, and 2.2 and 2. Yeah, here is the scatter plot. Yeah, and then we see that within the group itself, yeah, we have variations of value. This is variation of A, within group of variation of A, within group variation of B, and within group variation of C. Yeah, so this is the characteristics of the sample data. Yeah, so in each of the sample, we have within group variations, the values that wiggles within the group itself. Yeah, but among the group, we have also variations. Yeah, here we can see that the central tendencies, yeah, pretty much similar between A, B, and C. Yeah, let's see, 2.5 million and 1.4. If we divide it, maybe the center point is about, the average value is about 2 million, and for University A and University B also the average value is about 2 million. And so it's the mean difference among different samples are pretty much similar in example 1. But let's see for another example. In sample 2, we have also collected, yeah, in sample 2, we pick different respondents. Yeah, but here we can see the value has changed. If I make a scatter plot, A, B, and C, here we can see, yeah, for sample A, for example, this is 1.44, 1.4. Yeah, we have two respondents with monthly spending of 1.4, and then the third one is 1.5, and then the third one is 1.6. Yeah, 1, 2, 3, 4, 5. And then at Uni B, the lowest or the smallest monthly income, monthly spending is 1.7. Yeah, so here, yeah, let's see, and then 1.8, and then 1.9, and then 2 million, and then 2.1 million. Yeah, let's say here 2.1. And then if we come to C, the smallest spending is 2 million, about here. And then 2.1, 2.2, 2.2, and 2.5. Yeah, this is the third group, or Uni C. Yeah, here we can see, yeah, so this is the within group variations of Uni A, within group variations of Uni B, and within group variations of Uni C. Yeah, if we observe carefully, yeah, the central points, or the average value of each group compared to the other, or among group variations, is distinguishable. Yeah, so there is no overlapping zones like we see in example 1. Yeah, here we can infer, yeah, we have the initial inference that example 1, the mean difference here are null, or the mean value of university A, B, and C are similar. We can see that the tendency is there. But in example 2, the tendency is that the mean value of university A and B are different. Yeah, and uni C also different. Yeah, we can see. So that is the basic foundations of ANOVA. Yeah. So in ANOVA, what we do is we make a ratio between two different variables. First is the among group variations. How different is the value among one sample and another, and the within group itself. Yeah. So here, yeah, the within group variations is, how much is the difference between a value in a group and the mean value within a group. Yeah. So how, the variation within the group itself, within one group. And the among group variations is making comparison between the mean size of the group and the overall mean. Yeah, like here, what we do is the among group variations is that we have the mean of group A, B, and C, and then we compare it to the central mean. That is the among group variation. Yeah. So what we do in the basic intuitions is if the ratio between the among group variations and the within group variation is large enough, or if SSA is significantly larger than SSW, or within group variations, then we can infer there is a difference in mean value among universities A, B, and C. But if the ratio between among group variations and within group variations is small, then we can infer there is that the mean value of university A, B, and C are pretty much similar. And that actually what in technical manners, it drills down to the F-test formula. Yeah, mathematically we change, or we use the F-statistics to check whether the ratio between among group variation and within group variation is large enough or not. If you see the formula here, F-stat is basically the among group variation divided by the degree of freedom. So the ratio between the among group variations and the within group variations. But here we have to divide each of the variation value with the degree of freedom value. Here, for the among group variation, we have to divide the among group variation value with the number group -1, yeah, for the degree of freedom. And then we have the MSA value. And then here for the within group variations, we have within group variations, and then we divide it by number of group, which is 3, and the total number of sample. We have 5 in group A, 5 in group B, 5 in number C, and this is 15. Yeah. And we have the MSW. And then the F-stats is basically a ratio between the MSA and MSW. Yeah. We will discuss in detail in the problem set elaborations. And then after we have the comparison between the among group variation and within group, how can we decide whether this F-stat value is indeed good enough or bad? Or yeah, how can we decide whether the F-stat value indicates the acceptance of null hypothesis, which indicates that all of the means value are similar, or whether this F-stat value indicates that the null hypothesis should be rejected? Of course, we need critical value, and how we determine it? We use the F table, yeah, and then we pick, we locate the critical value, yeah, using the degree of freedom of the within group and the among group variations. Yeah, for example, if we have and then we locate, and then we have the critical value, yeah, and for example here, yeah, 4.533, and then we locate, yeah, F-stat, yeah, we calculate the F-stat. If the F-statistics value lies within the region of non-rejections, then we accept or we not reject the null hypothesis. But if the F-stat lies in the region of rejection, then we have to reject the null hypothesis. Okay, that is the philosophy of one-way ANOVA. In the next video, we will discuss in more detail, in a more technical manner, via the discussions of the problem set. Thank you.